When you are looking at amortizations, such as with mortgages, we've got the same root there of mort. And another example would be student loans. George has $10,000 to pay. He's supposed to pay it off in monthly payments in 4 years. So if there was no interest being added on to his loan, we could take that 10,000 and divide by 48. But every month, money is being added on so that it's fighting against his payments. The formula for amortizations, it is almost as if we have multiplied both sides of this equation by the reciprocal of what I had in the brackets. In fact, I think it's exactly the same. Okay, so I've replaced the periodic interest rate of little I with the R over M, and then N by M times T. I computed what 0.029, the annual interest rate, converted to a decimal by moving a 2 to the left. I divided that 0.029 by 12 to get this. And then down in the denominator, I add the 1. I raise that to the negative 48th power. All right, I had a little technical difficulty there with some programs freezing up. Bringing up the last question that we were working on. I may repeat myself a little bit, but if I remember right, going from finding the present value of an annuity to figuring out how much would have to be paid periodically for an amortization, it looks to me as if we have multiplied both sides of this formula by the reciprocal of what we have in the brackets here to get R alone, the recurring payment. Unlike the previous question, where I figured out what R over M and M over T were equal to separately. Here, I've simply replaced in the formula that I is equal to R over M and N is M to the T. We need that to be negative. And remember that if we had divided 10,000 by the 48 months that we have in 4 years, if there was no interest, then roughly George would be paying $208.33 a month. However, with every payment that he makes, he is having the interest working against him. So when we have divided R by M, converting that to a decimal, that's 0.029. M is 12. So when I divided 0.29 by 12, I got this. I've added the 1 to it in the denominator only, and I raised that to the negative 48 power so that we get a number smaller than 1. It's still positive though. Subtract that from 1 here. Notice that I have not bothered to multiply by 10,000 in the numerator yet. Well, then when we divide the 0.0024 something by 1.094 something, you're going to get something that's actually, hold on here. Let me do that the other direction. Give me a moment. Okay, so again, I have not multiplied by the 10,000 yet. If I take the decimal part in the numerator without any rounding, I'm saving the rounding for the end, divided by same thing. I have it rounded down here. Now, traditionally, we would do that division and then multiply by the 10,000. What I want you to see is that if I take the reciprocal of that, I'm getting an answer that's a little bit less than 48. Dividing 10,000 by something less than 48 is going to give me a larger answer. So he's going to be paying a little bit more than $208.33 per month. So I have that shown here. This may depend on the textbook that you're using or the directions given by your professor, but although there's a 1 in the place after the hundreds place, I've rounded it up anyway. I've seen some textbooks that say always round up to the next cent when you're figuring out what your periodic payment for an amortization is. And the reason for that is that might seem like very little per month to the person paying, but if you think about the banks, how many mortgages and how many student loans they hold, they're pulling in from thousands and millions of people that extra cent per month, so that in that last month, the person may have a little bit lower payments.